questions. Yes? Yes. I don't know. Is everybody's fourth one different? I think everybody's fourth one was the trig sub. But there were like 3 different versions of it. So basically, I mean, let me see. I'll kind of talk about the 2 types, or were there 4 versions? Oh, there were 4 versions. Okay. I'll talk about the 2 types that I put on there. Yes? Depending on which of the 4 versions you got, there were 2 types. One of them looked like this. Oh my God, poor little dude. Okay. Does that look familiar to anybody?
No.
Oh, I'm sorry.
It looks so familiar.
I like how you are. It makes as much sense as what you normally talk about, Jeff. Okay, I understand. There. Does that look familiar to anybody? Nobody had that one? That's weird. Because it was on there.
I had the one
Some
where
of you
it
guys
was
had a
like
9
flipped.
here, yes? Is that better?
I had the one where it was
Some
like
people had
flipped.
9, had a better memory? Okay. Some of you guys had one that looked like this.
Mhm.
Okay, so, right?
Mhm.
I'm not going to do these because you're going to be able to do the corrections, but I will talk about at least the first steps. How did you identify this was trig sub? By the way, if you didn't take a quiz, you're going to get a different version, so you'll be okay. How can you see that this is trig sub? Unless you're sitting over there.
Because there's no derivatives of anything in there.
Let me try this again, hold on. That's going to come. Alright, sorry. One thing, now he's like, oh, screw you. Alright, you guys, I'm sorry. You got one there. Oh! Okay.
Oh my God.
No! Alright, too bad. I'm just excited all the doors work, so I guess that's okay. It's gonna play, it's gonna tease you guys. I'm sorry. Okay. This is obviously, neither one of these is U sub. Is that cool? I'm just going to turn them off. Is that all right? I don't even know which one he is, so screw it. Is that an Epson? I think so. Let's see if this is, which one is this? That's that one. Okay. So it'll be this. Oh, I see what's going on. I think I see what's going on. No. All right. So he can just be this. Okay. All right. Let's see if he stays. Okay. Sorry, guys. Sorry. In order for this to be U sub, for example, what would have to not be there? What would have to be there? There would
the
have to
X
be
squared
these
on the
two
bottom.
can't be there, and there would have to be
And
an
there
X
would
on the
have to
top.
be an
Yes.
X.
Okay. We did an earlier problem where you don't need a radical, but if I see a radical with x squared plus or x squared minus or something minus x squared, that's an obvious trig sub. I see. In the first problem, I see a number minus a function squared. That's exactly in the same format as one of our main trig identities, yes? What trig sub should you use in the first one? Sine, because it's like 1 minus sine squared. But it's 9, so I'll let x equal 3 sine. Okay, beautiful. What about the other one?
Tangent.
There's trying to be a 4 there, poor little dude. Why tangent? Because the identity is
Because you've got something plus
good.
number.
The identity is tangent squared plus 1, so I would make it 2 tangent, so it'd match up with the 4. You guys with me? And then you figure out what dx is. Now, you could run into problems after that, but you will get a decent chunk of the points for identifying it and doing the right first step. After that, there are some places you can make mistakes, and then it becomes really difficult. You guys kind of with me? But neither one of them should have been sort of like when we did before the quiz. Okay, maybe. Is that all right? Is that better? Who asked me that question? Is that better? Oh. All right. So the only things that could really happen to you are number plus x squared, number minus x squared, x squared minus number. Yes? And of course, this one could be either way because addition does that. Which trig sub would this need?
Tangent.
Just like we said a minute ago. And of course, it would be like square root of the number in front. Yes? So let me put like this. So then that would have a number in front. So when you square it, it matches up with the number squared that's there already, and you can factor that out. So you have got to understand the idea behind these. You can memorize the substitutions all day, but it's much better if you understand the idea behind them, right? I'm trying to make another trig function show up that isn't two terms, it's one, because then I could take the square root of the damn thing, because most of these have square roots in them. And I'm hoping the dx piece, once I do that, it will have some stuff that cancels and makes it better, yes? Okay, maybe. No. Okay. So I gave you that handout that explains the identities and when to do which substitution. It's on you to explore why that makes sense and to try the homework out. If you have trouble with the homework, I don't know, I'm not going to say more about this. You know, there's a million different places you go for help. You just can't. If you know, and I think I talked to you about that, I talked to you about ChatGPT, for example, or Wolfram Alpha, or Photomath, or any of those things, yes? Those are wonderful tools if used correctly. ChatGPT, just how many people know about ChatGPT? Did I talk about it already?
A little bit.
Yeah.
Play around with it, it's amazing. Ask it to make a 6-word horror story. Or I've been asking it to write stories. I say, write a story about a young platypus trying to make his way in the world in the style of Mark Twain. Bam! It'll do it, right? And then you say, redo that and make it a little more action. Bam! It'll do it. It's stupid. It's insane. You can also ask it to do math problems. And the really insidious thing is it will make mistakes sometimes because it learns from us. And what are we infamous for? Making mistakes. Yes? You guys kind of with me? And why is that so evil? Because if you just copy it from your homework, it's harder for me to catch because it's not perfect. It makes mistakes. I'm like, well, shit. So at that point, the math department has already discussed this. We decided not to focus so much on people who cheat because that just makes it harder for the people who are just trying to do the work. You with me? So I'm leaving it up to you. You can cheat and die on the test. It's up to you. Homework is not worth enough to cheat on it. It just isn't. Okay. But here's a really good way to use ChatGPT. Feed it a problem, say, hey, what's the first step? Just tell me the first step, please, Mr. ChatGPT. Person, dude, I know you're not a person, sorry. Don't write all that, just say it. You with me? And it will tell you the first freaking step. Yes? No, careful, it could be wrong sometimes. And you can say, can you double check that? And I'll say, okay. You guys know what I mean? It's a really good thing because sometimes students are just like, if I just do the first step. You with me? Maybe. And then if you do a couple of those, you start to see, okay, why did it say to do that? What was it about the problem that said for me to do that? And you start to see what to look for, yes? This is why you need practice. If you do a bunch of different kind of problems, I'm hoping you start to see what the problem tells you. How does the problem communicate with you? Hey, human, do this thing. Okay, maybe. Is there a requirement to use ChatGPT? No, definitely not. If you don't want to, don't. That's fine. Don't trust the AI. Don't feed it. Okay. All right. Anything else that's well sitting in your brain from the quiz? Okay, so when I give it back to you on Thursday, you'll be able to correct it. Everything is always due the day of the next test except for homework corrections. So if you give me homework and I give it back to you, you have to make corrections, that's due the day of the final, yes? So to keep all the due dates straightforward, everything's due the day of the next test except for homework corrections. I like it. Okay. So, if there's no other questions, yes?
7.2, number 40.
Is that on?
Yes.
Good. 7.2, 40. All right, let's see. Does that look familiar to anybody? Not yet. No. Now, what's the immediate evil thing about that? What's the two main types of things we looked at in this section?
Is that it's not sine, cosine,
Sine, cosine?
or secant, tangent.
Secant, tangent. But why do we have secant, tangent stuff to look at? Because the derivative of either one is related to both or one of them, yes? Cosine and sine, they're related to each other. Secant and tangent, their derivatives are either related to both or one of them. You guys with me? So what is the derivative of cotangent, for example? Negative cosecant squared. Yes? So then you apply the same reasoning to this as if it was tangent and secant, except you're going to have some negatives. Because the co-shit always has a negative, which is another reason why we called it co-shit. When you first learn trig, you have no idea why we call it freaking cosecant. You're like, why isn't sine and cosine and secant and cosine? What the hell's wrong with you math people? Now you're starting to see, oh, there's connections. There's reasons these crazy people do this shit, I guess. So, on this problem, do you notice that this specific problem, if I try to let u equal cotangent, do I have what I need to take next to the d theta? If u is cotangent, what's du?
Cosecant.
Negative cosecant squared. So couldn't you take two of these over? Is there an identity between cosecant and cotangent? Damn straight. Tangent squared plus 1 is secant squared. Cotangent squared plus 1 is cosecant squared. So, I probably wouldn't do this to you on a test because secant and tangent are already gross enough already. But do you guys see how that's not that big of a step from secant tangent? It's the same thing. You're just kind of a negative to deal with in your derivative. Is that better? Real quick. Do you guys see I have two cosecants I can pull over? And I can multiply inside and outside by a negative, so then I can see my du, yes? The other two cosecants, can't I use the identity to write it in terms of cotangent? I need you to start seeing these problems at that level. If I let, let's see. So what's the first step here?
Take the two.
U equals
Cotangent.
cotangent. Yeah, the d theta. So du is,
Cosecant.
so I need to, don't worry about the limits and crap, I just want to focus on the main part of it. You guys have to worry about it. So I need to bring a negative, then I can bring a negative cosecant squared next to my d theta. That leaves two cosecants over here, yes? And I got my four cotangents here, yes? If I'm ever left with something, I need it to be squared because then I can rewrite it in terms of the other dude using an identity. If I started with three cosecants, this problem would suck pretty bad. Because then I wouldn't be left with enough cosecants to use an identity. So what am I always looking for with trig functions so I can maybe use a basic identity? I'm looking for them to be squared. Because every basic identity has squared trig functions in them, yes? Okay, maybe. Is that okay? Because now if I let u equal cotangent, the middle's easy. This will be u to the fourth. This will be du. And this I have to rewrite as no. 1 plus cotangent squared, that would become 1 plus u squared if I let u equal cotangent. Do you guys? So you are trying to pull something over to be du, and you're hoping what's left is squared or to an even power so you can use an identity to rewrite it in terms of what you're letting u be. That's the idea. Okay.
Why is the negative still?
It's gotta be. Because du needs a negative.
So then why is the negative out in front?
How did I get this negative here? Where did this come from? It wasn't there before, was it? So I needed to put a negative on the outside so I could put a negative on the inside, so overall I didn't do anything. Yes? It's the whole Indiana Jones, which, over the years, I'm an old man now, so everybody looks at me blankly like, what do you mean those stupid skulls? No, the first one, the good movie, where he took the the gold thing and you put the sand? Yes? So if I gotta balance things out. Yes? Okay.
Which clearly he didn't.
Huh?
Which clearly he didn't.
He did not. He should have taken one more math class. Too much archaeology for him. Dr. Jones. Okay. Anything else from homework stuff? Okay. All right. I have a feeling that's not the real answer to that question, but I can only do what you guys tell me. What I want to do is I want to focus on synthetic division, and then do some problems that are from 7-4, and then we'll see what time it is. That's what I want to do. What I could do is a few more things from earlier sections if there's still issues. So I'm going to pick this up. And oh, did you have a question? Yes. Okay. Go.
Homework. I'm
Yes.
on focus sign, so I don't know exactly what it is, but
Sure. Tell me what it says.
The indefinite integral of 2 times cosecant x dx.
Ooh. Okay. This one is one of the ones we. All right. Do you guys remember we did integral as secant? Does anyone remember the weird thing I had to multiply by? Okay. You guys don't remember this? No.
I do, I just can't remember what you had to multiply by.
So, real quick side note. If I had secant, if I multiply that by
Oh,
that is not obvious, but do you guys see how I get secant squared x, which is the derivative of tangent, and I get secant x tangent x, which is the derivative of secant? Is that obvious that that's what you do? No. So I explained to you while we did it that it was not obvious. But now you know how to handle secant. You also know how to handle cosecant because it's built off of the same idea. Okay. Again, I'm trying to figure out how to read your expressions. That is not obvious. But once I do it, do you see what it does for me? If I let u equal the bottom, won't the top be du? That's what it does for me. So you might say, why are you allowed to do that? Because I multiply same thing on the top and bottom. I'm always allowed to do that. Yes? Now you might be sitting there saying, that ain't the problem I had, math boy. How does that help me? Well, can you think about this problem, and the two can just come out of the way, right? Can you think about this problem and think about it the same way? Like, could you multiply top and bottom of this by something that would have the same kind of thing happen? Yes? Do you see what I mean? Again, this problem's a little evil because it requires a step that would be very difficult to come with on your own, which is why I did it with you. Yes? So cosecant works very similarly. Now, obviously, it's going to have some negatives possibly showing up because it's a codude, yes? And codudes suck. Cosine's an asshole, and the other codudes are related to cosine. So, okay. Now again, this is not immediately obvious. It requires you to play around a little bit, but you have a template to work from. I'll bet you it's going to be something like cosecant x plus cotangent x, but maybe it's not that. Maybe it's a minus in there. I don't know. Play around with it. You guys see what I'm saying? Play around with it. When you took trigonometry, I think you took trigonometry. Yeah. That trigonometry, pre-calculus, verifying trig identities. Do you guys remember that? Do you guys remember that? Where you had to make both sides look the same? So you could either start with one side or start with the other, or start with both sides and make them show that. That was the first time you guys should have gotten the chance to play with math. That was the first time when it was specifically true that a part of the process was to pick the wrong path. Yes? Pick the wrong thing. This is like that. You already have an example of a problem. Pick something, see if it works, see why it didn't work, adjust it a little bit. Yes? You have got to get to the point where you're comfortable with that. And again, I'm not saying you have to be able to tell that from the beginning, but now I've shown you that thing, and now you have a template for how to do other things related to it. Okay, I like it, maybe. Not an easy interval directly. If I just gave that to you, holy shit, you can kick me in the shit. Just without any but now you can't talk because I explained it, too bad. Your chance to kick me is gone. Well, you can still kick me, but bad things might happen. Like I'll have a hurt leg. Anything else? Is that okay? I think I saw you lit up a little bit, okay. Feel that, you guys. I want to make you, I'm a math teacher, so unfortunately I'm used to making people upset sometimes, but it's not me, it's the content. I'm always willing to help. If my office hours don't work, I can make time over Zoom. Okay. Anything else before we get back into stuff we did before? Yes?
Can you look at a problem from 7-4?
No, sorry. No, yeah. Can you imagine?
No. It's
Tired. Which one?
It's 72. I just don't know what it means.
Oh. Oh, I see. Oh, yeah. Okay, so this is one of those freaky things I'm talking about right now that it's a thing you wouldn't even think of to do. So you have to consider, I want to add and subtract the same quantity. So I want to take these 2 terms and make them 4 terms. So in the middle, I want to subtract and add the same thing. You guys with me so far? Is that something you would think to do? No, it isn't. If I have 4 terms though, do you guys remember what I can try to do? Factor-wise? A method? Starts with a G.
Grouping?
Grouping, yes. I can try to factor the first 2 and the last 2, yes. So maybe, just tell me, what's your immediate gut tell you should add and subtract so it's in the middle there? What would make sense? Just what makes sense? You can do it, come on. That's x to the 4th.
X squared.
Yeah, try to add x squared, subtract x squared. Or turn them around, right? Give it a try. Do you guys see what I mean? This is a beautiful example of a problem where you just have to play around with it. Will I give you a lot of problems like this on a test? Hell no, because that playing around part could take forever. Yes? It just depends on how quickly you guess the right thing or you see the pattern, and that might not come right away just because of luck. Yes? Maybe your luck stat's low. Pump them all in strength or something, I don't know. Okay. Barter? No. You guys kind of with me? This one's trippy. It's not immediate. Now it makes sense what they're asking, yes? It's a lot like, and again, remember in 180, when you had to prove the, I don't know if you did. You should have proved the product rule using the limit definition, and you had to add and subtract the same thing. Ain't no way in hell that a person just learning calculus would ever think to do that shit. But the minute that was done, should have realized, oh, maybe this will happen a few more times. Yeah. Okay. Is it okay? That's better. That's one of those problems where if that's the only problem that gave you a lot of trouble, you're doing great. That one's trippy. Okay. All right. I'll ask one more time. Anything else? You got one more?
So,
I know you got a lot. You got one more you can pick? No?
no,
Okay.
not really.
All right. I'll leave it alone. All right, guys. So I hope you start to realize, some of you guys have had me before, I work really well with a lot of questions. I just do. If I don't get a lot of questions, I'm going to keep checking in until you go a little crazy. Yes?
I found one.
Okay.
Number 30 on 7.4. I got as far as like when I separate, I got the what should be on the top,
Yeah.
what should be.
This one's a little trippy because how much can you factor the bottom?
Not very.
I mean, what's the only thing you can do with the bottom on this?
Take out an x.
Take out an x squared, yeah? Okay. So can everybody do the first couple steps on this? Unless you already did this, which I have a feeling not a lot of you have. So grab a sheet of paper, write this down. Just this piece, we're gonna do partial fractions. The integral is the last thing we'll worry about, yeah? Factor the bottom and try to write the form using ABC, whatever, yes? Let me write down the problem. I'll just look there, there we go.
X cubed plus 6x minus 2 over x to the 4th plus 6x squared.
Come on. So if I grab this part, pluck it out, put it here. Real quick. What is it about this that tells me I can start doing partial fractions? What is it about this problem?
You've got
Is it top heavy? Is it?
Bottom.
It's bottom heavy. So it's got to be bottom heavy in order for me to start doing partial. If it's not bottom heavy, what the hell does bottom heavy mean?
power is
The
higher
degree of the
than
bottom.
bottom.
Is higher than the top. If it's not bottom heavy, if it's equal degrees or the top is higher, you have to start with long division. Because part of it you're done with. Part of it's a whole piece. Like x squared plus 3, and you put that shit over there, and then the rest of it, the remainder is going to be the real fraction piece. Do you guys see what I mean? No. So anytime you have like a mixed number, won't you get a whole number and a fraction? Right? If you have an improper fraction, you'll get a whole number and a fraction. Same thing. Why the same thing? Because variables are numbers. So of course they have to act the same as numbers because they are numbers. So if I have a top-heavy dude and I do long division, I'll get a chunk that's a nice x squared plus 3 or something. It's just sitting there. It's beautiful. It's not a fraction. And then you have plus a remainder piece, which is a fraction. And that's the part they only focus on that part when you do partial fractions. That's kind of nice. Can I do that here? No, because the top is not top heavy. It's not. It's bottom heavy. Yes. So what's the form of this? You got to be really careful. There's going to actually. I'll tell you this. There's going to be 3 parts. Is something repeated? What's repeated? X. So I'm going to have something over x and something over.
X.
Yes. There. Because this is really a linear repeated. So that's why the top is constant. What about this dude?
He just gets one.
That's truly what degree? This piece. What degree is this?
Second.
Second. I really want you to see. This is second degree, but it's a repeated linear. That's why I get 2 with just constants on the top. This guy, what does he have to get on the top?
Cx plus d.
Yes, the bottom is truly squared. It's the second degree, so the top has to be in the most general first degree. Let me stop for a minute.
So if there is something that's
Repeated.
it's not
Yes.
going to have any x terms on the top.
As long as the thing that's repeated is a first degree. So
Okay.
what is it that's repeated? In the original problem, what is it that's repeated?
The x.
X. So it's going to have constants. If I had this problem, I know you can't see it. Do you see how that's a repeated thing?
Mhm.
So I have a over x plus b over x squared plus cx plus d over x squared plus 6 plus ex plus f over x squared plus 6 squared.
Okay.
The
So
thing that's repeated tells me what power the top has to be. Since this is a second degree thing that's repeated, the top has to be first degree. Okay, I wrote that really gross because it's not our actual problem.
so the top is always going to take the same form as
1 degree
as it
less.
would be if you were just doing the by itself and not it repeated.
Exactly. I like it. So I'll put A over X. So this is just
Long
B
way to
over
say
the
that.
repeated X. CX plus D over X, whatever this is. This is the X plus F, or the repeated X squared plus X. Okay. What's the next step on this? Go back. See if this guy's working. Yeah. Okay. I thought for sure it was going to blink out like that. What's the next step on this?
Kill fraction.
Kill them. Kill the fractions. Kill the fractions. So if I multiply both sides by this, did it just turn off?
Yeah.
Yeah. All right, screw them. Go away. You
It
had your
tried.
chance. Yeah.
It tried.
No, what I'm about to do is a pre-calculus level shortcut. I'm not trying to make you feel bad if it doesn't make sense. I'm trying to make you realize it should make sense. If I multiply by this, I'm going to cancel an x, and the a is going to pick everybody else up. So basically, each piece just picks up what it doesn't already have. So what am I going to put next to b? What's he going to pick up? Yes, because the x squareds would cancel. What am I going to put next to cx plus d?
X squared.
X squared. Cool. Because the x squared plus x will cancel. Yeah. Is there a value that you could use for x that would help you on the first step here? Because what really sucks
Negative
about
6?
this? What really sucks about this? How many things do I not know that I'm trying to solve for? How many things am I trying to solve? 4. 11. That sucks. That's a lot. There's a lot of things. The number of things we don't know is too damn high. It's a problem. I can use the shortcut once. Yes? And what I call a shortcut is letting x equal something, because that's nice, that's easy. What do I want to let x equal and y? WHY. There's no y. I want to let x equal 0 because kill some of my damn things I don't know. Yes, that's always nice. Now that sounds like generally a bad, it's not a life lesson. Don't kill the things you don't understand, okay? In mathematics, we could do that. If x is 0, what do I get on this side? -2, yeah. And that's 0, and that's 0, and I get 0 plus 6 times b, I get 6b. And now I know that b is
-1.
-1/3. Kicking ass. And now you have a few different things you could do. What I normally do is I kind of start with you can basically just multiply this out. You could put a -1/3 there, distribute it, pull it over here. Do you see how that's gross? Do y'all agree with me that's gross? Well, then don't do that shit. I'm going to look for things that involve b. Do you see how what? Just had my 4th puberty. Do you see how the constants involve b, but I don't get constant terms from these, do I? Do either one of these give me a constant term if I multiply it out? Nope. B is involved with x squared. Yes? Where do I get another x squared term? Nope. This will be ax cubed plus 6ax. Do you see that? It would be x cubed and x. This will be x cubed and...
X squared.
Do you guys see this? Do I have to multiply this shit out? No. Can you? Yeah, go ahead. You can, if you want to waste time. But I know this is bx squared, and I know this is dx squared. So what must b plus d be? 0, because there is no x squared term over there, so they must cancel each other for this to be a true statement. Does everybody see that? The x squared terms over here have to add to be 0, because there are no x squared terms over here. So in order for this to be a true statement, b plus d is 0, so that means I know what d is. What's d? 1/3, because b is -1/3. Yes? Yes? Nick?
Yeah.
Now you just start
Yeah.
going, you can go to your cubes. Do you see that? What is involved in cubes? A x cubed and c x cubed. So what must a plus c be?
1.
1. Now what sucks about this statement though?
That you don't know what A
Don't know either one, damn it! So what have I not used yet? I don't think I've used my just straight up x's yet. Yes? No, I haven't. That's awesome. What is the only term in here that gives me x? Obviously nothing here gives me something x, yes? Here, nothing gives me something x. Here, 6a. So what's 6a gotta be?
6.
6.
Negative 6.
So a is 1, and so c is 0. Cool. Yes? Maybe. There's several different ways to do this. You can do nothing but systems of equations if you really want to. I don't know why you'd want to. I'd say I always do this as much as I can, and then I start setting up systems, and I know some of the letters. That kicks ass. Worst thing about systems is when I got a bunch of stuff, if I already know a few things, they're easier. Yay. Now, of course, the next step, we're not done because we'd have to throw this in and then integrate, but basically we're done with the rough stuff. So, let me give you this. I can't remember if this really gives us, screw it, doesn't matter. It's just good to know. Here's a little something about synthetic division. Alright, so I don't think there's necessarily a problem in the homework you need this for, but anytime I can, I want to let people know about synthetic division. Do some problems require you do long division? Yes. Now, synthetic division kicks so much freaking butt. It's stupid. The one reason it kicks a lot of ass is because it doesn't always work. There are very specific situations it works for. It will only work if the bottom is linear, and it will only work directly if the bottom is linear slope 1. So basically the bottom is like x minus 3 or x plus 7, it'll work directly, beautifully. If the bottom is 2x plus 3, you gotta adjust it a little bit. If the bottom is x squared plus 7, you don't want to do that shit. Because then you have to synthetically divide by the square root of 7i, and I don't want to do that, I don't know about you. And then you have to divide by negative square root of 7i. No. Okay. Has anyone, I think I did a problem like this last time, I can't remember. But real quick, just to show you what this does, and why, very quickly. Do you guys see how when I long divide, I gotta subtract, which means change the signs? What's x to the 4th times x?
X to the 5th.
Positive x to the 5th. What's x to the 4th times 6? Positive 6x to the 4th. So why did I make them negative? Because of course the next step in long division is subtract, or otherwise change the signs. Yes? Change the signs and combine. So one thing synthetic division does is it says this. It says, all these letters don't mean shit. What is the most important stuff here is the coefficients, yes? When I do this and I get this here, this negative 2 is here because this was here, yes? Why was this negative 2 here? Because 4 minus 6 is negative 2, yes? That is the most important part of the first piece of this. So, synthetic division does two things. It says screw the variables. Just make sure everybody's in the right order. And if you're missing somebody, you put a 0. Yes? Okay. Right? That's what it says. It says, so synthetic division will only work if the bottom is linear, especially slope 1. And if you've got everything in descending order and everybody's represented. Yes? If you got all that, synthetic says, I got you. So it doesn't write any variables. It only writes numbers. And I want you to know this. So this sucks. Remembering to change a sign every frickin' time, yes? That's a really easy mistake to make. You guys with me? It sucks. So why don't we just change the sign? So screw the x and then make it a -6. So I change the sign once, right at the beginning, so I don't have to change it every time, and that's why there's a -6 here. Screw the x, change the sign first. Look at here. 4 minus 6 is -2. 4 minus 6 is -2. Do you guys see? Can you see? Okay. And then you can see very similar stuff happening further down, blah, 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 blah. So it's just a very much more concise way. If you did matrices, we're not going to suddenly do matrices. The only thing I want to point out is, if you do enough of them and you start to realize their importance, they make systems of equations so much quicker because they screw the variables, just focus on the numbers, yes? This is even better than matrices because I saw some reactions when I said matrices. Oh, sorry. This is so much better. Isn't that clean? What if I made something bigger? Wouldn't they just get longer and then you're just adding more stuff? Who cares? Yes? How do I interpret the answer? 1 degree lower than it was. Because in this case, for example, I was dividing 5 x's by 1. So of course I'm going to be left with x to the 4th. 1x to the 4th minus 2x cubed plus 12x squared. No x's, minus 8, and then this is my remainder over what I divided by, which is exactly what we do with frickin' numbers, yes? When the remainder, if I got a 6 remainder, wouldn't that be 6 over 7 if my division was 7? My divisor was 7, yes, okay. Same thing. Why do they work the same way? Because they're stupid numbers. That's all variables are. All right. How important is it for this immediate class for you to know synthetic division? No. How important is it for you to know it in general if you're going any further in mathematics? Very, very important. It's just such a good tool. It's a really quick factoring tool. So, look on the back.
Uh-oh, do we want to?
Let me see. Do number 1. What am I asking you to do on number 1? What am I asking you to do? I know it's a weird question. What am I asking you to do? Find the integral, yes? Did I say to do it a specific way?
No.
Did I say to do it a specific way? What do you try first? Do number 1. Don't start doing the hardest thing just because you're like, it looks like this. Always rule out the easiest thing, yes? Make sure I did this right. Yes, it is. Yeah. Does anyone see what I'm saying?
Maybe.
What do you rule out when I just asked you to do an integration? I didn't say to do it a specific way. What do you rule out?
U sub.
U sub. Will U sub work here? What's the only thing that makes sense to let U equal? The
bottom.
entire bottom. What's the derivative of the bottom? The freaking
Where
top!
it's cubed.
Shit straight! Do I have to do partial fractions in this dumb thing? But you guys see how you could all fall into that trap? You're like, oh, goddamn, Jeff. This is obviously partial fractions. Let me factor. No, U sub. Just do freaking U sub. You guys with me? Now, I'm not going to necessarily do this because it's a little evil, because if you don't notice it, you got this long-ass problem when you should have been done quick. That's a little evil. Yes? I do want to point this out. Whatever the problem is, don't make assumptions. Just try U sub first. Rule it out. Is everybody with me? So this first problem is easy. U equals bottom. What's du?
The top.
Top dx. Could you write this? Yes. Because I know what you mean. That's true, isn't it? So what does this become? It becomes integral of 1 du over u. What's the 1 over u integral?
Natural log of absolute value.
Kick ass. Of u, and what was u?
X to the 4th plus 2x
Plus-
cubed
yeah.
minus
Probably should write
2x
X
squared.
to the 4th, blah, 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 plus. Okay, you guys with me? You guys with me? So every time we learn a new method, that doesn't mean that everything that looks like that suddenly is that. Do you guys? Okay, I think you made your point, Jeff. Move on. So obviously, number 2, if you try to use U sub, you already know it ain't gonna work because the top ain't what it was. Too damn bad. So, let me ask you this question. what numbers, for number 2, make sense to put here? What numbers make sense to put here? Can anyone see? When you get this factored, what kind of numbers could be at the end? Could I have a 7 here at the end? Why not? You can do it. If I had x minus 4, x plus 2, x minus 1, x plus 1, and I multiplied out, what do I get at the end? At the beginning, I get x to the 4th. Is that cool?
Mm-hmm.
What number would be at the end?
1.
You could do it if I multiply all that shit out, and I don't want anyone to multiply this shit out, but I do want you to tell me if I did, what number would be at the end? 8. Yes? Negative 4 times 2 times negative 1 times 1. Now, do you understand? If you multiply the first two, you get negative 8, multiply the last one, you get 8, and multiply the last one, you still get 8 at the end. Yes? That's why that's a bit of a shortcut. What's the middle terms? Oh shit, that's worse. But you can see there would be an 8, yes? So if I had x to the 4th plus blah, 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 plus 8, I could try 4, I could try 2, I could try 1, I could try negative 4, negative 2, negative 1, I could try 8. I need factors of the number that's there. Because that's the only way it could be factored. So what numbers could you try in what I call the penalty box here? Can somebody give me one number that you could try?
Negative 4.
Do it again. What? Somebody say 8? Tears. What is the last number in this polynomial?
3.
So what kind of numbers could have possibly been at the ends? 1, 3, negative 1, negative 3. Anything else? No. So, give me one. Give me one.
3.
3! Okay. What do the coefficients of the bottom do?
1, 2, negative 2, 2, negative 3.
And nobody's missing, right? I don't have to put any zeros. I got everybody there. Bring down the 1. Multiply. Add. Multiply. Do you guys see something? Add. Should I keep going? Can you see how it's dead already? Okay, not a big deal. Now our list has 3 things in it. So what else could I put in there? So does everybody see how 3 does not work? How do I know it's not going to work? What would have to be here for it to go in evenly? The remainder would have to be 0. In order for something to go in evenly, it has to have a remainder of 0. Yes? So I can already see, ain't no way in hell it's going to have a remainder of 0. If you can't see that, 41, 123, 120. Yikes. Nope. Yes?
So how are you getting like the numbers in the second row?
Bring this down. Multiply, add. Multiply, add.
Okay.
Yeah, because that actually is what we're doing in the long division. If you really look back, that's the operations we're doing on the only numbers that matter. What other number could I put in here? 1. 1, 2, negative 2, 2, negative 3. Bring down to 1. Multiply, add. Multiply, add. Multiply, add. Multiply, add. Jeff, calm down. So what worked? What was this related to?
The factor version x
Yes?
plus 1.
No?
It's minus 1.
Yes, because I changed signs, remember?
Right.
1 is the root, x minus 1 is the factor it would come from. What's left over here? I had a what to begin with? 4th power. I divided by something with x, so now what do I have left? X cubed?
X cubed.
3x squared? Yes?
Mhm.
X? How many terms are there? What can you do?
Another.
No. I could do synthetic again, but do I have to? Do you guys see how what's going to work here?
Grouping.
Grouping. Well, grouping always worked when you have 4 terms.
Nope.
Nope. So if it didn't work, I'd have to do synthetic again. It does work. So I can just do that. What is the first step for partial fractions? Take the bottom and split it up, factor it, yes? Because then that tells me what parts I need to put on the other side. That's the whole reason we call it partial fractions, right? It's fractions that represent the parts. I'm gonna do whatever I can to factor it, and synthetic division is just one really freaking powerful tool I can use to help me do that. Grouping is an old tool. Way back. You guys learned grouping way long ago, but hey, look at it. Look at it making a comeback. How do I group that? What comes out? How many X's? 2,
One.
yep.
Oh,
X
What comes out of these two?
nothing.
It's not, there's always something that
You
comes
could
out. Always
Put,
something.
you do 1.
1, there you go. And then how do I write the answer now?
X squared plus 1, x squared plus 3.
No, x plus 3.
Or yeah.
I'm taking this x plus 3, there's just one x plus 3 out. There's one x plus 3 that was distributed, yes? So now, this is the bottom, isn't it? So now you see how you can write the parts. What would the parts look like? I'll get them started. A over x minus 1 plus. Good, because the bottom is truly quadratic, yes?
Mhm.
Plus.
D over x plus 3.
You guess. And then you can set that equal to this dude, right? And do all the steps. Yeah, okay. I think I'm gonna let us out our list plenty. We've been through a lot. I feel like you guys need just some time to yourselves. Please, I'm sorry. I don't want to make light if you're feeling overwhelmed. We've had one quiz. Every quiz is roughly 3% of your grade. Even if you bomb the hell out of this quiz, like it's the lowest grade I've ever seen in my entire life, you can come back from it easy. If you didn't quite finish on the homework, obviously you're not going to do as well on the quiz. If you didn't get help with the homework and maybe didn't really understand some of the problems, you're not going to do as well. Do you understand? So it's almost good if you can identify things you did not do and start doing them. Yes? And real quick, I don't know if I've said this yet, but if there's a test or something coming and you haven't done enough problems in this section, stop doing every single one of them. Start doing every other one. I'm still going to want you to do every one of them. You're going to say, I'm going to do as much as I can, man. You with me? I think I talked about it. Make homework your own. I'm going to still want everything. You're going to do as much as you can because you all got jobs, you all got stuff, you all got shit. You want to be prepared for quizzes and tests. Okay, I'll stop. There's another quiz on Thursday. Keeping it going. What's that quiz on? This stuff. I'm not going to put anything too weird on it, okay? You're all like, I don't know what your definition of weird is, Jeff.
It's just simple.
Just simple.
I
Thank you.
I